Okay, so when you're approaching this type, we've got to ask ourselves the question, is there a metal or not? So when you look at your periodic table, is either of those on there? Yes, we have strontium right there, right? So it's on the left-hand side of your periodic table. So once we know that it's ionic, that tells us for sure, no prefixes. That's your first thing, no prefixes, okay? It's most likely just naming as is, okay? So we know that we have strontium, so you can write that name, okay? You have strontium. What's the next question we got to ask before we continue on?
If it has a polyatomic.
No, not yet.
Transition metal?
Transition metal, good. So is strontium considered a transition metal according to your periodic table? No, it's all the way on the left-hand side. So it's in group 1 or 2. Group 1 or 2, we don't have to worry about transition metals. So we don't need any what? What's that purpose of that question? Roman numerals, right. So we don't have any Roman numerals in this list. So we just have strontium. Now we look at the next part of it and we ask ourselves, is that a what?
Polyatomic.
Is it a polyatomic? Are there extra oxygens attached to something?
No.
No. So we just have nitrogen. So what do we do with that? Nitride. Good. Strontium nitride. Okay? All right, let me move that off. Okay, so the next one I want you to do, I want you to have, I want you to write the formula for barium chloride. And I would like you to draw it. Okay? Formula and drawing. Now remember, this drawing, if it's ionic, is the bracket thing. So the arrows with the bracket thing. If it is covalent, that's when we do the dots and the bonds and things like that. Okay? So you got to figure out if it's ionic or if it's covalent. Okay, so I asked you for the drawing and I asked you to write the formula. So remember, with the drawing thing, that's where we're going to rely on where they're located on this periodic table. So barium is down here at the bottom, right? So we got barium down here. So how many valence electrons does barium have? 2. How many does chlorine have all the way over in group 17? 7. Good. So we're going to start off with the pictures of those two. So we have barium with 2 dots. We have chlorine with 1, 2, 3, 4, 5, 6, 7. Okay? So since we know it's ionic, it's not a sharing kind of bond. We aren't connecting the dots, right? We're sending it over with an arrow. We're showing that barium's going to donate its electron. Well, barium still has another one, so we have to draw one more chlorine here to show that he can get rid of him, and he just filled up 2 chlorine. So the after picture would be barium with a little 2+ charge and chlorine filled up completely with a -1 charge. So from this drawing, you can get your formula by just counting them, right? So you can always fall back on this as long as you're not dealing with transition metals and polyatomics. But so with that, we would just count it up as barium and 2 chlorine. So BaCl2 would be the final answer. Now the quicker way to come up with that formula, move these out of the way real quick. Okay, so the quicker way to come up with the formula is we would have Ba, he has a +2 charge, so worrying about the charges now, right? So he's in group 2, he's 2 away from going backwards to a noble gas. And then chlorine is 1 away from being a noble gas, so he is a -1. And you would take those 2 and you would crisscross them. So being ionic, you're allowed to crisscross charges. And so you would end up with BaCl2. Okay? All good still? All right, cool. So the next one I would like you to do let me go ahead and I'm just going to double this real quick.
16.
Mm-hmm.
Does that make it PO8?
It doesn't. So, so when you have one that looks like this, we ask ourselves, is there a metal?
Yes.
Yes, so we know it's ionic. So we're going to start with what our first guy is listed. So we have iron. But we notice that iron is where? What kind of metal is it? It's a transition metal. So that tells us that we need to figure out Roman numerals, right? So who do we pay attention to when we need to find Roman numerals?
First one.
Oxygen, the second guy listed, the anion, right? Because we know what oxygen's charge is, right? So we have FeO. Oxygen has a what charge? -2. How many of them are there? There's only one there. So -2 times 1 is a -2 overall. Has to balance out to be 0. So this has to be a +2, and then you always go back and check the subscript. How many of them are there? 1. So that equals a +2 charge. So we have iron, 2, and then how do we end this? Oxide. Okay. So another one similar to that. Let's do Cu2 CO3. So ionic or covalent? Ionic has a metal, so we're going to start by just writing out the name of our metal. Okay. Then we're going to realize that copper is where? He's a transition metal in the middle, right? So we have to look at our second thing listed, which is our anion. So we have carbonate, right? Carbonate has what kind of charge? So here, I'll show the work off to the side. What is the charge on carbonate? A -2. How many of them are there? How many carbonates are there? The whole thing. One. There's one carbonate. One whole polyatomic. Do you guys see that? It's not 3. There's 3 oxygens, but there's one polyatomic. Because if I had a 2 over here, then that would be a 2, right? But I don't. This is only 1, so -2 times 1 is a -2 charge, or sorry, yeah, -2 overall charge. We need to get to 0. So over here we have to have a +2, but how many coppers do I have? 2. So I have to divide that by 2 things to figure out that it's a +1 charge. So this is copper 1 carbonate. Okay. Okay. Let's try. This should feel a little easier. Do I want you to write out lead 4 sulfide. I want you to write me the formula. Okay. So first we would start with, what's the symbol for lead? Pb. What does this 4 mean? That's the charge. That's what we've been solving for, right? So this one you don't have to solve for. You just have to use it, right? So this is +4. Sulfide tells you what element? Sulfur. And what charge does that one have? A -2. So you take those values, crisscross them, and we get Pb2S4. However, we know that when it's ionic, what do we do to those numbers? Because it's a ratio. Remember, it's about that crystal lattice thing that I showed you in the lab, right? So we need to simplify these two subscripts.
S2.
Yes, PbS2. Okay. So just like a ratio, instead of saying a 2 to 4 ratio, we would say a 1 to 2 ratio. Okay. All right. How about we do 10 to sulfate. 10 to sulfate. So you recognize that it's ionic, so, and there's a Roman numeral in there, right? We don't really have those for the covalent stuff. So since we're just writing a formula, we're crisscrossing charges. So we're going to start with our first symbol. So 10 is who on the periodic table? Sn. The 2 Roman numeral tells us it's a what charge? A +2 charge. Sulfate is not sulfur. Not SO3. SO4. There we go. So sulfate is SO4 with a -2 charge, because we would find that on our list. So we would take those two values, crisscross them, and we end up with SN2, SO42, but because it's ionic, take those 2's and simplify them. So it's just SnSO4. Okay? Okay, the last thing. We have done, let's just do this one because it's fun. Dihydrogen monoxide. Okay, so what stands out to you in this one?
Die.
Yes. All right. So you have prefixes, so it's covalent. So now we don't have to do really any thinking work. You just got to know what your prefixes are. So di means how many? 2. So we have a hydrogen with a 2. Mono means 1. So that. Okay. Let's try. I give you XeF4.
That's gross.
So if you have to name that, they're both on the metal or non-metal side? Non-metal. So, good. So we have xenon. Okay. Did I have to put any prefixes in front of it?
Nope.
No, we don't put mono on the first one. And then we have tetrafluoride. Okay. All right. One more drawing one? Do you want a drawing one now?
Yeah.
Sure.
One more drawing, and then I'll review the rest of the period. All right. So let's do. All right, so let's do carbon disulfide. So before you go to draw it, what's easier is having the formula ready to go so you know who you're dealing with, right? That's why I'm giving it this one to you, okay? So carbon disulfide. So it's covalent. We would start with a C, because there's only one. How many sulfurs? 2. Okay. So when we go to draw it, we're going to start with NAS. Okay. So needed for the carbon and then the 2 sulfurs. So carbon needs 8 plus 8 plus 8. They all need 8. That's their goal. So we have 8 times 3, which is 24. All right. Available is your valence electrons. So carbon has 4, sulfurs each have 6. So we have 16. So 24 minus 16 tells you 8. And then we're going to take that and we're going to divide it by 2 every single time for this one, okay? So 8 divided by 2, which tells you 4 bonds. All right, so with those 4 bonds, now we're going to actually put it together. Remember, originally carbon looks like this. So it has 4 areas that it can bond with, right? And sulfur looks like this. So it has 2 areas it can bond with, okay? So when we go to do this, even just using our original rule, which is carbon always goes in the middle no matter what, okay? And we're going to start with carbon. But you realize that we only have 2 sulfurs, right? So we can't have this picture, right? We can't just put the 4 bonds all the way around. We're going to double bond each of those sulfurs. And then we're going to be adding extra electrons to which elements? The sulfurs. Good. I thought I could move that. Okay. The sulfurs. Good. So we need to get to 16. So far we have 2, 4, 6, 8. We're going to go to the sulfurs now. 10, 12. Okay. And then we double check. Is this sulfur full? Yeah, it has 1, 2, 3, 4, 5, 6, 7, 8. Okay, carbon is full. 1, 2, 3, 4, 5, 6, 7, 8. And then now we're going to fill up our other sulfur who only has 4 right now with those last 4 electrons. Now we have 16. Everybody has 8. Everything's good. Okay? Don't forget your exceptions. Hydrogen only needs 2. So basically hydrogens will bond and that's it. Don't put any electrons on your hydrogens. Anybody from group 17 will only bond in one area and then you fill up all the way around. Okay, kind of start realizing that the same groups are going to end up looking the same. Okay, so just kind of start making that connection as you're working through these. But you have your review, so you can work on that for the rest of the period. I will be posting the answers this evening. Okay, I will be available in the morning for tutoring as well if you need to come in and see me.